Welcome to our lecture series on trigonometry. Our first lecture in this series is on the basics of trigonometry. I am your lecturer, Professor E.O. Efanga. The meaning of trigonometry. Trigonometry is a branch of mathematics that studies the relationships between sides and angles of a triangle. The basics of trigonometry are the trigonometric ratios or trigonometric functions. The three fundamental trigonometric functions are sine function, cosine function, and tangent function. For any given angle theta, the fundamental trigonometric functions are abbreviated as follows: sine theta, cos theta, and tan theta. Real-life application of trigonometry is in the calculation of height and distance. Trigonometry is extensively used in the following sectors: aviation, navigation, criminology, marine biology, etc. Trigonometric ratios in right angle triangle. Given a right angle triangle ABC with angle ACB equal to theta, the side AB is the opposite side and it is denoted by small letter c. The side BC is the adjacent side and it is denoted by small letter a, while the side AC is the hypotenuse side, denoted by small letter b. We then define sine theta as opposite over hypotenuse, that is c over b. Cos theta is defined as the adjacent over hypotenuse, that is a over b. And tan theta is defined as opposite over adjacent, that is c over a. To remember these formulas, we use the acronym SOHCAHTOA, meaning sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. We observe that tan theta is equal to sine theta all over cos theta. Derived ratios in right angle triangle. The following ratios are derived from the fundamental ratios: cosecant, abbreviated as cosec theta, and it is defined as 1 all over sine theta, which is equal to b all over c, that is the hypotenuse all over the opposite. Secant is abbreviated as sec theta, which is defined as 1 all over cos theta, and that is equal to hypotenuse all over the adjacent. Then cotangent is abbreviated as cot theta, and it is defined as 1 all over tan theta, which is equal to adjacent all over opposite. Example 1. If cos theta is equal to 4 over 5, find the value of 1 plus cot squared theta. Solution. Let us draw a right angle triangle with angle ACB equal to theta. Then cos theta is given to be 4 over 5. That is, 4 is the adjacent while 5 is the hypotenuse. So we put BC equals to 4 and AC is equal to 5. Then the opposite side C can be obtained by Pythagoras theorem. So using Pythagoras theorem, C squared is equal to 5 squared minus 4 squared, and that will give us 9. If C squared is equal to 9, then C is equal to the square root of 9, which is equal to 3. Let us now find cot theta. Cot theta is adjacent all over the opposite. That is 4 over 3. So therefore, 1 plus cot squared theta is equal to 1 plus 4 over 3 squared. That is 1 plus 16 over 9. And that will give us 25 all over 9. Example 2. Given that cos theta is equal to r, where theta is an acute angle, find the expression for cot theta minus cosec theta all over sec theta plus tan theta. Solution. Let us draw our right angle triangle ABC with angle ACB equal to theta. We write cos theta as r over 1, where r is the adjacent side and 1 is the hypotenuse side. That is, BC is equal to r and AC is equal to 1. Then by Pythagoras theorem, we can obtain the side AB. That is, C squared is equal to 1 squared minus r squared. That is 1 minus r squared. If C squared is equal to 1 minus r squared, then C is equal to the square root of 1 minus r squared. Let us now find the expression for cot theta. Cot theta is equal to adjacent all over the opposite. That is, r all over the square root of 1 minus r squared. We also find cosec theta. Cosec theta is equal to hypotenuse all over the opposite. That is 1 all over the square root of 1 minus r squared. So therefore, the expression for cot theta minus cosec theta is equal to r all over square root of 1 minus r squared minus 1 all over the square root of 1 minus r squared. The LCM is square root of 1 minus r squared, and this will give us r minus 1 all over the square root of 1 minus r squared. Let us now obtain sec theta. Sec theta is hypotenuse all over the adjacent. That's 1 all over r. We also find tan theta. Tan theta is opposite all over the adjacent. That is square root of 1 minus r squared over r. So therefore, the expression for sec theta plus tan theta is equal to 1 all over r plus the square root of 1 minus r squared divided by r. The LCM here is r, so this will give us 1 plus square root of 1 minus r squared all over r. Therefore, the expression for cot theta minus cosec theta all over sec theta plus tan theta is equal to r minus 1 all over the square root of 1 minus r squared divided by 1 plus the square root of 1 minus r squared over r. And this is equal to r minus 1 over square root of 1 minus r squared times, you invert this to become r all over 1 plus square root of 1 minus r squared. So this will then give us r into r minus 1 divided by 1 plus the square root of 1 minus r squared times the square root of 1 minus r squared. Expanding the denominator, we will have this r times r minus 1 all over square root of 1 minus r squared times square root of 1 minus r squared will give us 1 minus r squared. Then plus square root of 1 minus r squared times 1 is root 1 minus r squared. So this is now the expression for cot theta minus cosec theta all over sec theta plus tan theta. Relationships between trigonometric ratios of complementary angles. In the right angle triangle ABC, that is in this triangle, if this angle is theta, then this angle is 90 minus theta. That is, angle ACB equal to theta and angle BAC equal to 90 minus theta are complementary angles. Two angles are said to be complementary if their sum is equal to 90 degrees. From this diagram, we see that sin theta is opposite over hypotenuse, that is C all over B, and that is equal to cos 90 minus theta. Cos theta is adjacent over hypotenuse, that is A over B, and that is equal to sin 90 minus theta. And tan theta is C all over A, which is equal to cot 90 minus theta. Example 3. If cos theta is equal to root 3 all over 2 and theta is acute, evaluate cot 90 minus theta divided by sin squared theta. Solution. Let us draw our right angle triangle with this angle theta and this angle 90 minus theta. Since cos theta is given to be root 3 all over 2, that means the adjacent side is root 3 while the hypotenuse side is 2. So BC is root 3 while AC is 2. Then the opposite side can be obtained by Pythagoras theorem. Using Pythagoras theorem, C squared is equal to 2 squared minus root 3 squared. 2 squared is 4, root 3 squared is 3. So 4 minus 3 will give us 1. So therefore C is equal to the square root of 1, which is equal to 1. We can now find cot 90 minus theta. Cot 90 minus theta is equal to C all over root 3. That is 1 all over root 3. And sin theta is C all over 2. So therefore, cot 90 minus theta divided by sine squared theta is equal to 1 over root 3 divided by the square of 1 over 2, which is 1 over 4. So 1 all over root 3 divided by 1 over 4 will give us 4 all over root 3. We have come to the end of lecture 1. Thank you for watching and keep on watching.